बताओ, visible है?
Yes,
हाँ
sir.
सर।
Yes, sir.
यस सर।
Okay. So now today we are going to discuss about the modeling part. In the previous class, we have discussed about the different, the specific, the you can say that about the transfer function. What is the meaning of transfer function? What is the type and order of the system? We have, I think, find out how the transfer function we will derived. We have seen now today the we have a problem of mass damper problem, and you are aware from this problem because in the control theory it is a very well famous problem. Okay, so in the mass damper spring problem, there is a three components. First one is the mass, second the damper, third one the spring. Okay, and another one the maybe the friction. Okay, so for the if any force is applied on this mass in the upward direction, then it means the displacement will occur. The it is the let's say there is a force, then obviously the displacement will occur in the form of this. Suppose you have applied Ft, force Ft on this mass, then the displacement will occur xt. Okay, and the whatever the force, the balance force will occur in the spring and damper is shown here. Due to the mass, it is well known. It is the m2 d2x by dt square. And for the viscous force, or you can say damper, it is in some book it is represented by the dx by dt, or in the some book it is written fv dx by dt. Okay, both are the same symbol. This is a damping coefficient. Fv is the damping coefficient in the into dx by dt. Okay, and if we're talking about the spring, then it is simply kxt. Okay, so these are the three components: spring, mass, and viscous damper. Okay, and due to this the force is balancing on due to these forces. Okay, so ft is nothing but the force due to the mass, force due to the viscous damper, or force due to the spring. Okay, so where k is the Hooke's constant, as you know, the Hooke's constant, right? So just you can take the Laplace transform, and when you are taking the Laplace transform, you have to keep in the mind all the initial conditions should be zero, all the initial conditions should be zero, and then you have just taken the Laplace transform of this one. So m becomes ms square xs plus fvs into xs. Okay, plus kx of s, or ft हो जाएगा fs, right? So you can derive the transfer function. Displacement is the output and the input is the force. So output upon input by considering all the initial condition zero in the Laplace transform is defined as the transfer function, and this is equal to 1 upon ms square fbs plus k, right? So this is the problem you have to solve. You already know this theory in your BTech courses. So it is the one of the problem, assignment problem. Try to solve. If you face any problem, you are free to ask the question, your query, right, in order to solve this question. Okay. So now come to the next part, that is the chemical process model. So let's say we have a simple tank system in which the Qt is the flow rate. This Qt is nothing but the volumetric flow rate. Remember, this is the volumetric flow rate. However, the output Q naught T, it is again the volumetric flow rate. So it is the since it is the volumetric flow rate, then the unit of this volumetric flow rate is nothing but the meter cube per second or meter cube per hour. Okay, and st is the level. Now our target is to control these levels. Okay, so before the controlling the level, we have to develop the model of this process. Okay, so in the PCI lab, in the process control instrumentation lab, due to the COVID, you are not able to physically present or physically see the equipments available in the lab. So you have to We have to simulate the same thing. We have to develop and simulate the same thing on the MATLAB environment. Okay. So now we are going to develop the model of this system. So how the model will developed? So we have to write the three equations we have already seen. First one the mass balance, second is the component balance, third one the heat balance or the energy conservation. So here the mass is entering and mass is leaving the system, and therefore mass transfer is enough to describe this model. Okay, and therefore we are simply writing the mass transfer. So mass transfer is nothing but the volumetric flow rate. Okay, so kg per you can write. Okay, so please see, this is the density. Density is nothing but the mass upon volume, and mass is the nothing but the kg per volume meter cube, right? And since this is, we are writing the mass transfer equation. So can you tell me what is the ultimate unit of this equation? क्या होना चाहिए? Since we are writing the mass transfer, so the exact unit of this model should be, please, should be, sorry, sorry.
हेलो
हाँ बोलो बोलो, सुन रहा हूँ.
मास ट्रांसफर इक्वेशन ना.
हाँ यस. Sorry. Say loudly. kg. kg ना.
हाँ सर.
We are writing the transfer. Okay, so transfer is happening with some rate na. So mass is transferring from with some rate, right? So kg per r or kg per second should be there. Kg per r or kg per second, right?
Yes sir.
So this is the density is equals to mass upon volume, and qt is nothing but the volumetric flow rate, that is the meter cube per second or meter cube per hour. Right, when you solve these two terms, then you will get kg per second, and ultimately this is the mass transfer. Mass is entering with this rate. Okay, and in a similar way this mass is leaving to this from the tank from this rate, right, kg per second. And now come to the accumulation part. In minus out equal to accumulation, and accumulation is nothing but d by dt, और किसका? kg का. तो kg per second होना चाहिए. तो kg per second के लिए what will do? So density is nothing again mass upon volume, and area is meter square. So you can write kg mass upon volume. This is meter cube. Area is meter square, and h is nothing but the level, and level is expressed in terms of meter. So again it was a meter cube and meter cube. Again d by dt is also there, 1 upon second. So ultimate equation is, ultimate unit of this is kg per second, right? Any problem? So kg per second this one, kg per second this one, and kg per second. So this is the balanced equation. So in minus out equal to accumulation, right? So by this principle you can write this equation. Hope you understand.
Yes sir.
Yes sir.
Okay, and then okay, the next part is now very easy. The density of this liquor or liquid, whatever the entering in the tank and leaving the tank, all are the equal, right, or constant. So we can cancel this density. This density is a constant. Area is again constant. Area is this one A. The area is A. Okay, and the level is H. So again area is a constant. So you can write Q2 minus Q naught T is equals to AdH by dt. So by solving this equation, you will get this one. Now come to the next part that is very, very important. And the part is, now this Q naught is leaving the tank with the help of some valve. Here there's a valve attached here. Okay, and this valve is maybe controlled. Okay, so the characteristic of this valve we will read after some time, after 10 to 15 lecture in the final control element chapter. about the characteristic of valve. The valve characteristic valve may be the linear in nature or maybe in the non-linear in nature. Okay, the valve may be the linear, maybe the non-linear in nature. So based on this characteristic, if this is the linear, if this is the linear, then the variation of this H and Q naught is in the linear fashion. That is, Q naught is varying with the H in the linear fashion. Okay.
Proportional.
Yes. So Q naught is equals to H by R. Q naught is equals to H by R. If the R resistance is increasing, it means Q naught will decrease. Okay, and vice versa. So there are two types of the laminar range. Okay, laminar range, that's a Reynolds number. It is decided by the Reynolds number. If the flow is in the range of the 1800 or 2100, the Reynolds number, then it is a laminar range. However, if it is greater than the 4000, then it comes in the category of turbulent flow, and characteristic becomes nonlinear. Okay,
Sir,
so
in some places it's mentioned that Rayleigh number above 3000 is turbulent flow.
maybe actually 2100 के ऊपर turbulent characteristic आने लगता है, but in some book it is written 3000, in some book it is written 4000. No problem.
Okay, sir.
Okay, so it is not very hard and fast tool. The ultimate crisp, the conclusion is, can say the variation of this Q naught and H is in the linear fashion. That is in the that depends on R. So Q naught is equals to defined by the H by R. Q naught is equals to H by R, right? So now just put this value Q naught is equals to H by R. So Q is equals to H by Q minus H by R is equals to AdH by dt. Just putting this value here. Okay, so this is equation number 3. Okay, now come to the next part. Now let's say your problem is occurred at the steady state. After some time or after a long time, the system is achieved in the steady state, at the steady state, right? And at the steady state, there is, what is the meaning of a steady state? You can tell me? What to understand by the steady state? Please, steady state का क्या मतलब है? Please.
That is not changing with time.
Changing with time. Okay. So the steady state, yani there is no accumulation. Accumulation becomes constant, or you can say changing with time. No, changing with time means what? D by dt is equals to 0. Yes or no? D by dt of something is equal to 0. And what is the accumulation here? Accumulation is happening in the terms of the level. So the dH by dt at the steady state becomes 0. There is no accumulation. There is a constant. Height becomes constant, and therefore the rate of change of height or the level becomes 0. And therefore at the steady state, if we can write that at the steady state Qs, this is the steady state value of Q minus of Hs divided by R is equals to the value of this dH by dt is equals to 0, and overall it is 0. So now this is the equation number 3 and equation number 4. Now we are subtracting the equation number 3 to 4. So Q minus Qs, H minus Hs by R is equals to A. Remember what I am writing. The equation, why it is 0? The equation is 0 due to the d by dt of Hs equals to 0. Am I right?
Yes, sir.
So d by dt of Hs equal to 0, and therefore when you minus this equation, so A d by dt of H minus Hs. Am I right?
Yes, sir.
Okay. So this is equation number 5. So Q minus Qs, H minus Hs by R, and A into d by dt of H minus Hs. Okay. So there is a deviation variable now. We are defining Q is equals to Q minus Qs, H is equals to H minus Hs. Q minus Qs is capital Q, H minus Hs is capital H, H minus H is capital H. Just we have defined. And taking the Laplace. So it is now it becomes the equation becomes Q is equals to 1 by R H प्लस ए डी बाई, अभी क्लास में हूं मैं, बाद में करता हूं, ठीक है, डी बाई डी टी ऑफ एच, ठीक है, ये हुआ ना. नाउ जस्ट टू टेक द लाप्लास ट्रांसफॉर्म, take the Laplace transform of this equation. So what will give? It will give Q is equals to Qs 1 by R Hs, or since it's the first derivative, then it becomes A into this is S by putting initial condition 0 SHs. So by solving this equation, you can find the output is level, the input is flow. So output upon input is equals to R tau s plus 1, where tau is equals to, you can write AR. Tau is equals to AR. This is the first order differential equation. First order differential equation. Okay, first order differential equation. So you have to remember it. If any of the tank is given, so the single tank is given, then the order, the first, it represents the first order system. It represents the first order system. Now we will see what happened when the number of tank will connected in different fashion. Okay, so now come to the next part, that is very important. Again, this is the, you know, okay, okay, first order nonlinear system. Okay, first order nonlinear system. What happened when the valve is the nonlinear? Okay, valve is considering as a nonlinear. Okay, so see, let's say here in this case, in the first case, we have simply defined the valve characteristic by Q naught by H. Q naught is equals to H by R. Q naught is equals to H by R. So it represents the linear characteristic. However, when this is the, when I say this is a non-linear, when it follows the non-linear characteristic, okay, so it means it is defined like this one. We have taken it as an example. Okay, so Q naught is equals to C is a constant, H valve constant, H to the power 1 by 2, or you can say root H. So this is the, you know, this is the non-linear in nature. Yes or no? It is a,
Yes,
a
sir.
linear or non-linear? Since due to
Non-linear.
the root, it is a non-linear, right? So just we have written the equation Q
So we have
minus.
taken it arbitrarily.
Sorry,
Sir, we have taken it arbitrarily.
we have taken the non-linear example. Simple.
Okay, sir.
Okay, we will see in the final control element there are different types of the linear and non-linear type of the characteristic. That is one of them. This is the one of them, right? This characteristic is resembling with the one of them. Okay, so this is a separate issue. Let's say we have taken this as a characteristic of the non-linear characteristic of the valve, right? So now the linear equation, the differential equation becomes Q minus Q naught is equals to AdH by dt tha in the previous equation. If you remember this QT minus Q naught AdH by dt. So QT, right? QT, and this is the Q naught T, and Q naught T is nothing but the CH T to the power 1 by 2, right? 1 by 2 A d by dt of what? HT. This is the equation, right? This is the equation. Now, in order to find out the, you know, transfer function, in order to find out the transfer function, we have to, there, you know, there's a, if the equation is a non-linear, there's a no method to find out the transfer function. Transfer function
Taylor's method.
you can't be able to find. Okay, so what we have to do? So one of the easiest technique employed in the different literature is the linearization technique. Okay, linearization technique. We are trying to make the linear equation with the help of this non-linear equation near the steady state point. Remember, this is all. This is there is the limitation of the linearization technique, and what is the limitation? The limitation is it only valid to their steady state value, near the steady state value, around the steady state value only, around the steady state value. If your steady state value will change or they are changing. Okay, so at that time, this value will always the whatever you have found a transfer function will not represent the accurate answer or accurate transfer function
Sir, if the steady state changes.
if the steady state value changes. What it mean? I will just tell you. इसका क्या मतलब हुआ? First, I'm coming to this. What is the meaning of linearization? Linearization is just a simple method to convert this nonlinear equation in the linear fashion. How? With the help of the Taylor series expansion. With the help of the Taylor series expansion, we can write this Q naught H. This is a Q naught H. What is a Q naught H? Q naught T is equals to C H T power 1 by 2. Nothing else, right? May be extended around the steady state value HS. Why? Because this is the after some time it will attain a steady state value. It will attain a steady state value, right? So if your QT and if Q naught T is changing in another fashion, or you can say there's a reference value. Let's say we have the first reference value, this one. We want to follow this input, and then after some time, after T time, you want to follow this input. It means your steady state has been changed. Or after some time, after T1 time or T2 time, your target is now changed. Okay, to follow this one. Okay, at that time your steady state value is also changing from this duration. For this duration, the steady state value is this one, and for this one, this is this one. Okay, so based on this value, you have to decide your steady state value. Okay, so my point is this one. My point is only this one. This Q naught H may be only expanded around this steady state value. Okay, how? Because you can see what the Taylor series you already studied in the mathematics. So Q naught is equals to first Q naught HS plus first derivative Q naught dash, or you can say d by dt of Q naught T HS. Okay, what is this HS? HS is the steady state value. Remember, this is the steady state value. Okay, H minus HS. Then we have taken the second derivative 1 upon factorial 2, second derivative HS, H minus HS whole square. Then 1 upon 3 factorial, third derivative of HS, okay, H minus HS whole cube, and like that. Is it clear?
Yes,
Up
sir.
to this point, any problem?
No, sir.
No, sir. So okay. So now we can write this equation Q naught is equals to if you are avoiding the higher derivative equation. Why we are avoiding? Because if you have take this there is a perturbation, there is a change in the H minus H is very small. This value is very small, and it will give
It
the
tends to
square
zero.
root of the small value is always small. Okay, it is more small than this value. Okay, and there's no significance of this value. Okay, so next we have written the first order value Q naught is equals to Q naught HS plus first derivative this one. Okay, so a square term, cube term, and another term, higher term, we can avoid it or diminishes. So you can now just, our target is to find out the Q naught dash. So just you can find out the Q naught dash HS. So you can take the derivative of this one. So simple C H power 1 by 2 hai. You can take 1 by 2 है ना, 1 by 2 minus H of to the power minus 1 by 2. Is it clear?
Yes, sir.
Okay.
Yes, sir.
So ये आपका बन गया. Now just put this value. Now put this value Q naught is equals to this value, right? तो ये बन के आ गया आपका Q naught is equals to Q naught after solving this equation. Q naught ये total value. Now we are putting like from this, na? Or this becomes Q naught as H minus HS by R1, right? Equal to ADH by dt. Am I right?
Yes, sir.
Yes or no? Yes or no? Okay.
Yes,
So
sir. Yes,
what is
sir.
R1? R1 is nothing. Here it is defined. Here this value is defined. Okay. And Q naught, what is the Q naught S? Q naught is equals to Q naught HS. Just put this value. Just this put this value here in this equation, and you can solve. After now, After just take the, just we will define the
Sir, at this point, what is
R1 is
how?
again, this is the wall resistance, and it is defined like this one. Solve this equation,
Okay, sir.
na? Just put this value and try to solve this
Sir.
equation. What will be and
Substitute,
define
sir.
this R1. Okay, so hence this equation becomes A dH by dt, A dH by dt plus इसको इधर ले जाएंगे plus H minus Hs divided by R1 Q minus Qs, Q minus Q. This is the steady state value. Take the Laplace transform. Then again define the Q H minus Hs as a derivation variable. This is a capital H. Q minus Qs as a capital Q. Okay, right? And take the transfer function. Okay, and you can solve the R1
First
upon
order to
tau
the
s plus
bottom.
1. Again, the same equation where tau is equals to again A R1. Okay, and R1 is defined like this one. If you have any doubt, you may ask. Otherwise, I will proceed further. It is okay?
No, no,
No,
sir,
sir,
no
clear
doubt.
है.
Okay. Next. Now, since this equation has only one variable, क्या variable है हमारा? Division variable is the HS. Okay, H is the only variable.
Height
Now
linearization.
let's say we have a non-linear model. A non-linear model, x dot is equals to fx u, x dot is equals to f of x comma u. This is the x is the state variable, u is the input, and y is equals to g x of u. This is the state variable and the u is the input. This the equation represent the state space equation of any nonlinear, simple nonlinear model. Okay, nonlinear model. It is a representation of any nonlinear model. Let's say. So here, what we have to do for the linearization technique, how the linearization technique will be applied. Okay, and this f is nothing. This x1 is, let's say, x1 dot is equals to f of x1 comma u. Okay, and let's say x2 dot is equals to f of x2 comma u2, and xn dot is equals to f of xn. It is just like you can say the vector. Okay, so simple, you can write x dot is equals to f of capital X comma u, where x is nothing but the x1, x2, and xn, right? And capital U is nothing but the u1, u2, and like that. Okay, okay. So this is the this is a different equation. So sorry, you can solve also f1, f2, f2, f1, f2, f3, and like that. So there are number of function is there, number of function is there, and there are number of variable. So in that case, how this the value, how the linearization technique will apply, we have to learn. Okay, so now see, first what we have to do, first we have to find out the Taylor expansion again. How the Taylor expansion will, let's say we have the fi or f1 or f2 equation we have taken. So we have to differentiate one by one, the function one by one. Okay, so let's say we have taken fi. Okay, and the neighborhood, this differential equation, the Taylor series will be expanded in the neighborhood of the some perturbation. Okay, or some, you can say, the disturbance. So that steady state value is here defined as the x naught u naught, right? X naught u naught हमने, let us consider किया, we have the x naught u naught, the steady state value here in the neighborhood of this we have to differentiate. Okay, the initial value is this one. Okay, so now just differentiate fi x naught u naught plus first derivative into change in the first. Here you also have taken the change in the first, h minus hs. We have taken x minus whatever, x1 minus delta whatever. Okay, and plus dot 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 differential of n a differential. Okay, और हमने del x ले लिया, right? Plus ये किसका हो गया? It represent for the x, and same the differential will be done for the u. Is it right or not? Are you able to understand, or any difficulty you are facing? Please reply. समझ में आ रहा है या दोबारा बताऊं?
सर और एक बार बता दीजिए
सर
प्लीज.
एक बार रिपीट कर दीजिए.
Okay. So x dot equals to, this is the simple nonlinear model. Okay, and this nonlinear model represents a vector type of the equation. Okay, what is the vector equation? Just you can write f1, f2, f2, f3, f2 up to fn. So this is f1 xu, f2 xu, f3 xu, and like that. Okay, and also this, there are number of state variables there, x1, x2, x3, x2, x, and all, right? And again simple for the u1, u2, u3, un. Okay, so how the Taylor series will be applied to linearize this equation? Okay, so for that purpose, first we have taken the nearest point or the neighborhood or the initial value. We have taken equilibrium point. We have taken x naught u naught. So near this equilibrium point or the neighbor, the initial value, we have expand, okay, the equation or f function. So function we have taken first. Let's say we have taken the f1 function or f2 function or fi function. Let's say we have taken I function, fi. So how it will be expanded? You can say fi x naught u naught plus first derivative into the change in h minus hs, or simply here x minus this one. Okay, and so on to the xn, right? And similarly you can write the derivative for the u1 also. Okay, fi u1, fi fi, okay, first derivative, second derivative, third derivative, like that to the un, right? So now we have taken the equilibrium point. That equilibrium point we are considering 0. We are considering equal to 0. Okay. So now if it is 0, then what happened? Then it will be represents, you can say here f of xu, simply f of xu is equal to nothing but the this value plus this value. Okay, we have just avoiding the higher derivative. So this will cancel, this will cancel, and in similar way the u value and the x value will remain. So
Most
क्या
of them
बचा?
are cancel out.
पहला वैल्यू बचा, समझ में आ रहा है? और क्या बचा? इनका फर्स्ट डेरिवेटिव वाला x वाला टर्म बचा एंड फर्स्ट डेरिवेटिव वाला u टर्म बचा, राइट?
तो
रिमेनिंग
बाकी सब कैंसिल हो गया ना?
बाकी सब कैंसिल नहीं हुआ, जस्ट वी आर अवॉइडिंग द हायर डेरिवेटिव
ड्यू टू नेग्लिजेंस.
due to negligible value, yes, right? So now just we are writing what? Fi, we are just generalizing the equation fi xu minus of fi xu minus of fi x naught u naught is equal to f delta f of x1, right, and delta f of u, right, delta f of u1. ठीक है, और ये जो आपका देख रहे हैं ये सब हायर टर्म है, ये सब हायर टर्म है. इज इट क्लियर?
हाँ सर.
यस और नो?
Yes, sir.
ओके. इफ यू हैव, अब नाउ, अब मैंने ये बताया आपको कि x1 के लिए आपने अभी हायर टर्म तक डेरिवेटिव लिया था. फिर से मैं बोल रहा हूं, रिपीट, x1 डेल्टा f ऑफ डेल x1 डेल्टा ऑफ डेल्टा 2x स्क्वायर, ऐसे करके x1 आपने हायर डेरिवेटिव लिया x1 का. नाउ if this x is consisting of x1, x2, x3, xn vector, this x is of the xn vector, then we have to take the first derivative of all these x1, x2, x3, xn. Am I right? In similar way, u1, u2, u3, un. If I'm not wrong, then you have to take, yes or no?
हाँ सर.
So it means fi xu minus of fi x naught u naught equal to what? Delta fi x1 near about this value, delta fi upon x delta x2, delta f on delta xn, समझ में आ रहा है? n variable, right? Or delta x1, delta x2, delta x3, delta x1 may be written like this one. Okay. In similar way, for the u value, we can also write this equation. For u1 value, for u2 value, for u3 value, okay, for un value, we have taken the first derivative and just writing the derivation. Okay. Is it clear?
हाँ सर.
So ultimate equation is your becomes fi x u minus of fi naught x naught u naught is equals to this value into this value into this value. Is it okay?
तो बहुत बड़ा हो जाएगा.
बहुत बड़ा नहीं होगा, देखो So now what we have taken, delta f1 delta x1, delta f1 by delta x1 to the delta f1 by x1 xn, राइट। ये फंक्शन हो गया f1 का x1 x2 x3 x4 xn के हिसाब से, x1 variable, x2 variable, x3 variable, xn. This, let's say we have the f1 function x1 x2 dot dot xn, okay, and u1 u2 dot dot un. In similar way, f2 function is defined x1 comma x2 comma dot dot xn, u1 u2 dot 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 un. In
हाँ
similar
सर
way,
समझा।
the fn x1 x2 dot dot xn minus of u1 comma u2 dot 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 un. Now, first what we have taken for the function f1, we have taken the derivative of with respect to x1, with respect to x2, with respect to xn. Is it okay? In similar way, for the now f2 के लिए किया del f2 upon del x1, del f2 by del x2, del x2 by del x3, del f2 by del xn, ये कर दिया। In similar way, del f1 n upon del x1, del fn f1 fn by del x2 up to the del fn upon del xn near about the x0. So this is the A matrix. This one is the A matrix. In similar way, we can write for the u1 u2 un. So del f1 is by del v1, del up to the f1 um. Okay, this is the m number and this is the n number. Am I right? So we
हाँ
can
सर।
write A and B matrix. In similar way, for the C and D matrix for the output equation we can write. Okay, is it clear?
हाँ सर।
Now come to the next value, that is the now this matrix is known as the Jacobian matrix. This matrix is known as the Jacobian matrix. Okay, so when you are using the NRM, Newton-Raphson method, okay, Newton-Raphson method for the non-linear equation, okay, for the non-linear equation, we are using simply such type of Jacobian matrix, okay. So Jacobian matrix at that time we are using, or in order to that, it is a very tedious task to find out if the number of equation, if the number of simultaneous equation is higher, okay, is higher. So this is the limitation, this is the limitation of this techniques. If the number of equations or if the number of you can say to determine, to evaluate the Jacobian matrix, okay.
Sir, the complexity is the drawback.
Complexity is the drawback, but you know, the you can solve, you can, if you are able to find out, you know, the Jacobian matrix. You know, in the industrial problem there are number of variables are present for in order to solve one particular problem. Let's say we have the 16 equation and 16 variable. In the case of one of the cases I have shown you, that is the multiple stage evaporator, I think, multiple stage evaporator that have the 7 stages, okay, and that 7 stages, if you develop the model, then 14 variable model, 14 variables equation with 14 equation will come in the picture. Or it is not very easy to solve the simultaneous 14 equation with 14 variable with the help of this Jacobian matrix. Okay, so in such type of problem we are utilizing the, you know, the optimization technique based on the meta heuristic approaches, or you can say the swarm intelligence type approaches, right? So both are the nature inspired, you can say in the word you can say nature inspired algorithm.
So, क्या meta?
Meta heuristic, just read these terms into the Google, okay, Google करो इसको, देखो क्या what are the things. Meta heuristic, I am again repeating, meta heuristic approaches. What is this? Just to Google. And another, you can say also this thing is a nature inspired algorithm. Nature inspired algorithm. algorithm. Just try to search on the Google. Okay.
Okay.
Now come to the next part. I think time is over. Time is not aligned. Okay. So just I'm just stopping here, and in the next class we will discuss about more about the model of the mixing process, heating process, blending process, and then we will draw also the some distributed parameter, lumped parameter, and another type of model in the next class. Okay. So thank you.
Thank you, sir.